Have you ever just stopped and wondered how your favorite apps seem to know you? How your music service can instantly pull up a playlist you made years ago? Well, a huge part of that magic is this kind of hidden language that organizes pretty much all of the world's information. And today, we're going to pull back the curtain on it. It's called SQL.
I mean, really think about it for a second. You log into an app and poof, there's your profile. Your music service knows every playlist you've ever made. Your shopping site remembers what's in your cart. That's not some kind of wizardry. It's a database. And the language that's used to talk to that database? Yep, it's almost always SQL.
All right, so here's our game plan for this explainer. First, we're going to cover what SQL actually is. Then we'll follow a single query on its little journey. After that, we'll dissect the database, check out some of SQL's real power tools, and wrap up with the simple rules for writing it yourself.
Okay, let's dive right in. What is this language that's basically running the show behind the scenes of our digital lives?
So SQL stands for Structured Query Language, and basically it's the universal standard for talking to something called relational databases. Now that sounds complicated, but it's not. Just think of them as databases that organize everything into these neat little tables, kind of like a bunch of spreadsheets all linked together. SQL is like the master translator that lets us ask this gigantic library of data for one specific thing and get a perfect answer back, like instantly.
To really get a feel for how this works, we're going to follow a single request, which is called a query, from the second we type it to the moment we get our answer back. You'll see it's a surprisingly smart and efficient little trip.
So it all happens in 5 key steps. First up is the input. That's just you typing in your command. Next, the database has to parse it. It's basically checking your grammar, making sure the request even makes sense. The third step, and this is where the real genius is optimization. The database figures out the absolute fastest, most efficient way to get you your information. Then, step 4, execution. It actually runs that plan and grabs the data. And finally, number 5, the output. You get your answer. So we know how the query travels, but where is it even going? Let's take a look at the structure of the database itself. And honestly, the best way to picture this is to think of a huge, perfectly organized digital library. And this analogy just works perfectly. The entire database, that's the library building itself. Inside that library, you've got your tables. Those are the bookshelves, right? Each one holding a specific topic, like users or products. And on those bookshelves, you've got the rows, which are the individual books. Each row is a unique record, like your specific user profile or one specific product.
But that brings up a really important question, right? If you have millions of books, or in our case, rows, you can't just go wandering down every aisle checking every single shelf. That would take forever. So how in the world does the database find exactly what you're looking for so ridiculously fast?
The answer is something called an index. It works exactly like those old-school card catalogs in a library. You know, the ones that told you precisely which shelf and which row to find a book on. An index does the same thing for the database. It points directly to the data's location. That's the secret ingredient to SQL's incredible speed. Now, finding data is one thing, but SQL has some other incredibly powerful tools in its toolbox that let developers and data analysts do some truly amazing things. Let's look at a few of the big ones. These tools just add whole new layers of power and efficiency. Take a view, for instance. You can think of it like a saved, custom-made window that only shows you the exact data you care about without messing with the original tables. Then you have stored procedures. These are basically saved scripts, a bunch of SQL commands you can run over and over with just one call. It's a huge time saver. But the real powerhouse here, that's joins. This is what makes a relational database relational. Joins let you connect the dots between different tables, like linking a user to all the products they've ever bought. This is the feature that turns simple lists into this powerful, interconnected web of information.
I know this all might sound a little complex, but you'd be surprised how straightforward the basic grammar of SQL actually is. Let's just quickly go over the core rules so you can see what it's like to actually write it.
Really, there are just 3 main rules you got to remember. First, you end every command with a semicolon. Think of it like a period at the end of a sentence. Second, all the key words like select or from, they're case insensitive. You can write them in all caps, all lowercase, doesn't matter. And third, any chunk of text just needs to be wrapped in single quotes. That's it.
The naming rules are just as simple. When you're naming a table or a column, it has to start with a letter. After that, you can use pretty much any combo of letters, numbers, and underscores. This one little rule just helps keep everything organized and way easier to read. Oh, and another super useful thing. You can leave notes for yourself right in the code. We call them comments. The database completely ignores them, but they are incredibly helpful for explaining what you were thinking to other people or, let's be honest, to your future self. For a note that goes on for a few lines, you just wrap it up like you see here.
So when you boil it all down, SQL isn't some super cryptic code for geniuses. It's a logical, really powerful, and actually pretty accessible language for asking questions. It's the key that unlocks all the stories hiding inside our data. And now that you've got a feel for this language, the only real question left is, what will you ask?